Okay, for x not equal to 4, the function h of x is equal to this function. What value should be assigned to h of 4 to make h of x continuous at x equals 4? The function is not defined at x equals 4, right? Because that makes the denominator 0. So that's not in the domain. But they're saying, okay, everywhere else, this is the function. But at 4, I want to give it some value so that the function becomes continuous. And what value should I give to x equals 4? So visually, I don't know how that looks like, but let's say this is how it looks like, right? So it's not defined at 4 everywhere else. Let's say that's the graph. So I need to put in a value here so that it becomes continuous. So in this case, it should be the thing that is the limit from both the sides, correct? The tests for continuity are, there are 3 checks, right? 1, limit, I'm writing for this function, x tends to 4, h of x exists, right? Number 2, h of 4 exists. Number 3, limit x tends to 4, h of x equals h of 4. So for it to be true, these 3 have to be true, right? H of 4 does not exist right now, right? We have to introduce that. And the limit has to be same as that. So I need to figure out what this limit is, right? And now this is where you are, right? So you say, okay, let me try to factor it. What is the numerator factored? And x approaching 4 means x is not equal to 4. So this is not 0. We can cancel this. And now we can plug in and then we get a 9, right? And this will exist because after we add it. So if we define, we have to define it to be something. So this works. If the limit has to be equal to h of 4, so this should also be 9, right? So we should say set h of 4 equal to 9, right? So what kind of discontinuity was this? Removable, right? So we can remove it by setting one value.